All right, so here's what the experiment would have looked like. Each of you would have gotten 8 of these things in the lab, and the idea is we grew these in the shade, under some shade cloth, or in full sun. That's what you've got back here. And then what we did to give you 6 data points for population growth, we either started them at N2, at 2 individuals, or 15 individuals. So we did that for both of them. Right, so the idea is that your N0, N, the population size on day 0, is either 2 or 15. Then we started some 7 days ago and 14 days ago. So all you have to do is count how many of these little duckweed are in here, and you can see how they're kind of like little lily pads. So the shade is the easiest one. I'm probably not going to make you watch me count all of these, but the basic idea, everyone knows how to count. 1, 2, 3, 4, 5, 6, 7. So we can write a 7 in here. Great. 23. 20. 57. Now all you have to do is estimate the geometric growth rate. That's really easy. So it's undefined for day 0, but for day 7 it's just simply this number divided by this number. So it's 7 over 2, n7 is 7. N0 is 2, 7 over 2 is 3.5. For day 14, it's 14 divided, it's n at day 14 divided by n at day 17, so n14 is 20. N7 is 7. So we use the 7 twice. Sometimes that confuses people. So we'll say it's 2.86. Do the same thing down here, right? N7 divided by N0 for the ones that started at 15, 23 over 15. We'll say it's 1.53. And then again, N14 divided by N17 is now 57 divided by 23. We'll call that 2.48. Good. So those are the calculations a single group would have made for shade. And now we can just do the same thing for sun. 14. 62. 40. Now the big one. 90. So that is the entire lab exercise, and now we can once again calculate the geometric growth rate, right? So it's undefined at day 0. At day 7, it's simply 14 divided by 2. So N14 happens to be 14 divided by 2, 7. Here, it's N14 divided by N7, 40 divided by 14, 2.86. Again, for this row, it's N7 divided by N0, so that's simply N7 is 62, N0 is 15. .13, and then again N14 divided by N7, 90 divided by 62. Call that 1.45. So you can already see some things that are pretty intuitive here, that the population growth rate is potentially faster in the sun, right? The geometric growth rate. These numbers are bigger in the sun than they are in the shade. But you can also see that they're potentially starting to slow down already as they get into phase 3 of growth. in the population process. So the whole goal of today's lab is to think about these population level processes, how the sun and the shade might be limiting the growth of these things, and also how to get some use with the population models. And so what you've got is the data from a couple previous years all mixed together, where the students, each group did this, and now you have all the data. So you have the n values, the population sizes at different times, and you have the lambda values that result from the geometric growth that happened. And the lab exercise tells you how you can use some really basic tools in Excel to estimate R, which is the intrinsic rate of growth of the population, and K is the carrying capacity. You also might want to think about, in this funny situation, whether it's only resources that are limiting the population size of these lily pads inside of this confined space.